Hi you guys, today's lesson is on translating context to numeric expressions. So before you get started, I want you to make sure that you have this notes guide and practice problems. And if you are at home in quarantine, please make sure that you print that out before you get started. So let's go ahead and start with the part on your first page that says Larry has a piece of rope that is 12 feet long. Okay, so we're going to start right here. Larry has a piece of rope that's 12 feet long. He cuts 25% of the rope off. How long is the rope now? Okay, so if Larry starts out with a rope that is 12 feet long and he cuts off 25%, one of the things that we need to realize is that a percentage is just a part of the whole. So he's cutting off part of this rope. 25% written as a fraction would be 25 hundredths, and that would simplify to 1/4. Okay, so he's cutting off 1/4 of the rope. So if we take the rope, the 12-foot rope, we divide it into 4 because we know he's going to cut off 1/4 of the rope. If we take 12 and divide by 4, each of those pieces would be 3 feet long. So we can see there is a picture right here for this situation. Each of the 4 pieces is 3 feet long, and if he cuts off 1/4, that means he's going to cut off one of these, he will be left with 9 feet of rope. Now this lesson is on writing numeric expressions for different situations. And so now we're going to talk about how we can write the math for this situation. And there are actually 2 different ways that we can do this. Okay, now remember in math, the word of means to multiply. And so in this situation, we had to figure out what 25% of the 12-foot rope is. So if we're finding out what 25% of 12 is, we take the 25%, we change it to 0.25, the word of means times, and then we multiply by 12, and that gives us 3. So 25% of 12 was 3. Now if we are going to write the math for this situation, here's one way that we can do it. We started with the 12-foot section, and then we subtracted 25% of 12. Okay, so the 12-foot section, then we subtracted 25% of 12, which was 3, and then 12 minus 3 leaves us with 9. Another way we can write the math for this situation is we can realize that if Larry is cutting off 25% of the rope, and the rope starts out as 100% of the total, if he cuts 25% of the rope off, he's going to be left with 75% of the total. And if there is 75% of the rope left, we can actually take and find 75% of 12 by doing 0.75 times by 12, and that leaves us with 9 feet of rope. Okay, so right here, you can take the 100%, you can subtract out the 25%, which gives you the 75%. You can multiply by the 12, and that leaves you with 9. Now, both of these expressions work. These would be called equivalent expressions. They both give us the same answer. So let's look at another example, and let's look at 2 different expressions that we can write for the same situation. Right here it says, Joe has a rope that is 25% longer than Larry's 12-foot rope. How long is Joe's rope? Okay, so we know Joe's rope is longer than Larry's rope by 25%. It's 25% longer. So the picture right here shows us that we start off with a 12-foot rope, okay? And then this 12-foot rope is going to increase in size. It's going to be longer. And the amount that it's going to be longer is 25%. Okay? So we know that if we find 25% of 12, that was 3. And so if Joe's rope is 25% longer than Larry's rope, we have to take the 12 feet and we have to add 3, and that will end up giving us a 15-foot rope. So that's our situation. Now let's look at 2 different ways we can write an expression for this so that we can write out the math for this situation. The first way is that we can find out what 25% of 12 is by doing 0.25 times 12, and we know that that's 3, and then we can add that to the length of rope that we started with, and that gives us 15. Okay, so the first way that we can write an expression for this situation is we can take the 12 and we can add 25% of 12, which is the 3, and then 12 plus 3 is 15. Another way that we can think about this, though, is we can think about it as we're starting out with 100%, okay, that's the 12 feet, and then we are adding 25% because Joe's rope is going to be 25% longer than Larry's rope. That gives us 125%. Okay, so if we take and find 125% of 12, to do that, we would change this to 1.25 times by 12, and that also gives us 15 feet of rope. Okay, so we can add the increase of the 25%. We can multiply that by the original amount, and that also gives us our 15 feet of rope. So both of these expressions work. They're both correct. They're equivalent expressions. Okay, so let's try a few more of these. We're going to take a situation and we are going to write the math for it. And there is more than one way that we can do that. So number 1, the tree in Maria's yard has grown 27% in the last 2 years. If it was originally 12 feet tall 2 years ago, how tall is the tree now? So we're writing an expression for how tall the tree is now. If the tree in Maria's yard has grown 27%, that means that there is going to be an increase. Okay, so we're going to be adding 27%. It was originally 12 feet tall. Okay, so here we go. There's 2 different ways to write the math for this. The first way is that we can take the 12 feet tall that the tree was originally, and we can add 27% of that, and that will tell us how tall the tree is now. So let's do that way first, and then I'll show you the other way. Okay, so we need to do this multiplication first. 27% of 12 would be 0.27 times by 12, and that is 3.24. And then we add that to the 12, so we end up with 15.24. Okay? Another way we can do this, though, is we can say, okay, the 12 feet that it was originally, that's 100%. And the trees increased by, or grown by 27%. And if you add 100% to 27%, that becomes 127%. It was originally 12 feet tall, but it's now 127% of 12. Okay? So we can now change this 127% to 1.27. We can times that by 12, and when we do that, we get 15.24. Okay, so either way we look at this, either expression that we write, Both answers give us a 15.24. Okay, let's look at the next situation. It says, Paulo can run a marathon in 4 hours and 20 minutes. If he's able to cut 18% off his time, how long will it take him to run a marathon? Okay, so if he's able to cut 18% off his time, how long will it take him to run a marathon? That's what we are trying to figure out. And if he is cutting 18% off, that means he's going to do the marathon in less time. We're going to be subtracting from what he could run it in originally. So 4 hours and 20 minutes. Let's just change this 4 hours and 20 minutes to just minutes. Okay, so we know that there are 60 minutes in 1 hour. So if we take 60 times 4, that's going to be 240 minutes. And then if we add 20 minutes, that's going to be 260 minutes. Okay, so we know that Paulo can run a marathon in 260 minutes. One way we can figure out the answer for this is we can say, okay, well, he's able to cut 18% off his time. Okay, so we would take and find 18% of 260, and then we would have to subtract that from 260, and we take care of this multiplication first. So we would do 0.18 times by 260, which is going to be 46.8, okay? And then we would take 260 and we would subtract 46.8, and that gives us 213.2 minutes. Okay, so 213.2 minutes. And we know that there are 60 minutes in 1 hour. I'm going to let you leave this just as minutes though. Okay, so 213.2 minutes. Okay, so that's one way to look at it. Another way to look at it is that if he can run a marathon in 260 minutes, that's 100%, right? That's the total. It starts out as 260 minutes. If he's able to cut 18% off, 100% minus 18% is 72%. That means he can actually run the marathon in 72% of 260. Okay, 72% of 260. And that would look like this, 0.72 times 260. And actually, let me back up. Sometimes when I am doing these, I make mistakes, and I apologize about that, okay? But 100% minus 18% is actually 82%, and I'm sure that some of you are thinking that, okay? So he can actually run the marathon in 82% of 260 if he cuts 18% off from what he started at. So if you do 0.82 times by 260, you are going to get 213.2 minutes. Okay, so either expression that you write or use gives you the same answer in the end. Okay, so let's do the last one. Joe's snowboard is 140 centimeters. Carly's is 14% longer. How long is Carly's snowboard? Okay, so Carly's is longer than Joe's. And Joe's snowboard is 140 centimeters. Carly's is 14% longer than that. So one way we could write an expression for this is if we take the length of Joe's snowboard, which is 140 centimeters, and we add 14% of 140, that would tell us the length of Carly's snowboard, because Carly's snowboard is 40% longer. Okay. So 14% of 140, we would first change this to 0.114 times by 140, and that gives us 19.6, and then we would add that to the 140, so 140 plus 19.6 is 159.6, and that is centimeters. Okay, so that's one way we could do it. Another way we could do it, though, is we could say that Joe's snowboard is 140 centimeters, so that's the 100% that we started with. And if Carly's snowboard is 14% longer than that, so 100% plus 14% is going to be 114%, we can then take and we can figure out what 114% of 140 is, okay? Because Carly's is 14% longer. So now we would change the 114% to 1.14. We would then multiply that by 140, and we get the same answer of 159.6 centimeters. So either way works. I want you guys to use whatever makes the most sense to you in these situations. For 4, 5, and 6, I want you guys to go ahead and pause the video, and I want you to do 4, 5, and 6 on your own. And when I correct through your packet, I will be looking to make sure that the situations, the context that you are writing matches these expressions. Okay, let's look at number 7. It says, below are 4 expressions. Circle the 3 that are equivalent. So A, that's the situation where you have 100% minus 35%, which would be 65%, and then you're timesing that by the 423. Okay, so that would be A, 0.65 times by 423. And that would be 274.95. Okay, now we can see that B is 0.65 times 423. So these two would actually be equivalent. Now we just have to figure out which is the third one that's equivalent. Okay, so if we take C and we figure out what 35% of 423 is by doing 0.35 times 423, and then we subtract that from the 423, that gives us 274.95. Okay, which is what we got here. So we know that C is equivalent, and then if you take 423 and you subtract 0.35, that is not the equivalent expression. So for that one, it should have been A, B, and C. Okay, so for this next part, we're going to follow the instructions here that say for each of the 5 contexts below, there are 4 numeric expressions offered. Look at each expression offered and determine whether or not it is appropriate for the given context. Explain why the expression works or doesn't work. So for each of these, we're going to be given a situation, and we need to figure out if the math that was written for that situation will work for the situation. And then we say yes or no, why or why not. So here we go. Josh made 5 3-pointers and 4 2-pointers at his basketball game. Write a numeric expression to represent how many points Josh scored. Okay, so A, here's a numeric expression. We have 1, 2, 3, 4, 5 3-pointers and 4 1, 2, 3, 4 2-pointers. I think that should work. Let's evaluate it. So if we take 3 and we times by 5, that's 15. And then 2 times by 4 is 8. 15 plus 8 is 23. And does that one work? We should say yes. That one works. Okay, let's look at the next one. 5 plus 3 plus 4 plus 2. That one does not work. That is not 5 3-pointers and 4 2-pointers. 5 plus 3 is 8, 4 plus 2 is 6, and 8 plus 6 is 14. Okay, these are not equivalent. Okay, let's look at the next one. 5 plus 3 is 8, 4 plus 2 is 6, and 8 times 6 is 48. And this does not represent the situation either. Okay, and then the last one, 5 times 3 is 15, 4 plus 2 is 8, 5 plus 8 is 23, and yeah, that one works. This would be 5 3-pointers and 4 2-pointers. And if you add those together, you get 23. And then on your paper, I want you to write why or why not. Why do these not work? What's wrong with these ones? Okay, and I'm okay if you don't write why it does. I want you to write in why it doesn't. Okay, let's look at the next one. Carlos bought 2 apples for 30 cents each and 3 pounds of cherries for $1.75 a pound. Write a numeric expression for how much money Carlos spent. Okay, so this is showing 2 pounds of cherries for $1.75 and 3 apples for 30 cents each. So that does not work. And if we evaluate this, this would be $3.50 plus 90, and that would be $4.40. Okay, and does this work? I don't know why I wrote yes. This one would not work. Okay, the next one shows 2 apples at 30 cents and 3 pounds of cherries for $1.75 a pound. This one does work. And that ends up being $5.85. Okay, the next one shows 2 apples at 30 cents each and 3 pounds of cherries at $1.75 a pound, and that one would work. And when we evaluate that, we see that our answer would be $5.85. And then the last one, 2 plus 3 is 5, and then 30 plus $1.75 is $2.05. And if we take 5 times $2.05, that one is not going to work. That does not match the situation. Okay, so if we continue on this one, we will see that all of these are equivalent expressions. All of them give us the same answer of $1.50. There's just 4 different ways of doing the problem, of finding the solution for how much money Inez spent. Okay, now at this point, I want to give you an opportunity to practice some of these with some feedback from me. So I want you to do number 11, number 12, number 13, and number 14. Once you have completed those, I want you to come and check them off with me. Remember, for each of these, I want you to say whether the expression works or not. Does the expression fit the situation? So, does it work? You're going to say yes or no. You're also going to evaluate the expression. So you're going to simplify it. You're going to figure out the answer. If the expression works, if they're yeses, your answers should match up. Okay? And then if the expressions do not work, if you get a no, I want you to tell me why they don't work. Okay? So you should be able to finish this before you leave today. So you are doing 11, you're doing 12, you're doing 13, you're doing 14. You're checking them off with me, and then we will continue with this lesson tomorrow.